Alright, hello, welcome to my B.E.S.T Geometry EOC practice exam. This is a 15 question geometry practice exam which is designed to prepare you for the EOC exam at the end of the year, which is about a month from when this video is going to post. So like I said, 15 questions. My hope is that I can provide some extra studying assistance over the next month while you prepare. We're going to go into great detail, or as great a detail as I can, on each of the 15 questions in this test. And hopefully I can provide you with the knowledge and background that you need to answer questions like the ones you see here. And this is going to be a longer video, but please stick with me, watch it in multiple parts, feel free, and hopefully by the end you'll feel more confident to take the exam. So let's dive right in. Alright, so let's get right into it. So here we have question number 1. A rectangle and a vertical line are shown, and the question is asking us to pick which object is going to be generated when we rotate this rectangle about the vertical line. So the important thing to notice here is that there is some air gap between the vertical line and our rectangle. What that means is that when this object performs a full rotation, if we perform that rotation here, this shape that we've made is a cylinder, and the cylinder is going to be that air gap. That's the way I think about this, at least. So this cylinder here is made of air, so we should expect whatever shape that we create with this rotation to have a hollow center. And you can see here, the only two shapes with a hollow center are B and D. And you should be able to directly see at this point that we're going to end up with B, seeing as we've made a cylinder air gap here. But if you weren't quite sure, you could continue to perform this rotation in your head in order to verify that. And what that would look like, at least again in my view, is I take this corner here, and I can rotate him around too. And now we're looking at the top of the shape, and this would have some depth as seen by that depth there. And again, we can imagine the base of the shape looks something like this. And again, it's a bit of a crude drawing, but you can see pretty clearly at this point that we are going to be pretty close to our object B versus all the other ones. What they're trying to get you to, there's a few points here just to note. A is, I think, what they're trying to get you to think the answer is here. If you don't notice that there's that air gap. Again, I'm going to delete my kind of crude drawing here. If you don't notice that this air gap is here, you're going to try to pick A. Now, if this rectangle had actually extended all the way, the answer would be A, because there would be no center core drilled out, there would be no air gap, and the rotation would directly cause A to happen. But in this particular question, that air gap is there, so we're going to choose option B. Okay, question number 2. We're given lines F and H are parallel and intersected by line Q, as shown in the diagram below. Now, we are to select statements and then select a reason to complete the proof, showing that the angle measure given by 3 is congruent to angle measure 6. So here in the diagram, we can see that there are 8 total angles that are given, which is in this diagram here. And then I've drawn out the specific answers in each of the drop downs. So here we have question number 1, which is statement number 2, and it's asking us to provide the statement that is given by the reason corresponding angles of 2 parallel lines cut by a transversal arc congruent. The first thing to do here, especially in a testing environment, is to eliminate the answers that we know are false. So if we look at our drop down for 2, the options are 1 is congruent to 6, 2 is congruent to 6, or 5 is congruent to 6. So all these have 6 in common, so let's go look at 6 here. I've circled it. And looking at 1 and 6 are clearly not going to be congruent. 1 is an obtuse angle and 6 is an acute angle, so we can directly throw out option A. What about option B? B is given as this angle here, and if you know your congruency relationships, you'll know that these guys are indeed congruent, and they are congruent by corresponding angles. But let's go ahead and look at option C just to show that you can throw 2 of the 3 of these out right out the gate. Here we have 5 and 6, and you can look at this and clearly see 5 and 6 are not going to be congruent. In fact, they're going to add up to 180 degrees. And that leaves us, we've already decided this, but that leaves us only option B is correct for statement number 2. Let's look at statement number 3 now. Vertical angles are congruent, and again, let's see if we can throw some stuff out. I'm going to erase 6, and I'm going to circle 3. And the reason I'm doing that is because each of the 3 options down here has 3, and we're going to check 1, 2, and 5. So again, 1 is obtuse, 3 is acute, so we can throw 1 immediately away. What about option 2? 2 is congruent, and 5 is obtuse, so it's not going to be congruent. So again, just by a direct process of elimination here, we've determined that 2 and 3 can really be the only option with regards to congruency here. And they are vertical angles, so you can see here that we've got 3 and 2. It's getting a little messy in there. 3 and 2, as well as 7 and 6 are vertical angles. And then same with 1 and 4. Anything you have that's going across the transversal is going to be congruent. And we know that from way back at the beginning of geometry, when we were studying congruent angles. So we know that, let's box our answers here because it's going to be important when we come to the next section. So 2 and 6, and we chose 2 and 3 right here. So now the question is going to be asked, okay, now that we know that 2 and 6 are congruent and 2 and 3 are congruent, we can tell directly that 3 and 6 are congruent. And I've written the statement for drop-down options here. This is going to be the transitive property. So we can immediately choose the transitive drop-down here because I have the following statement, which is if 3 is congruent to 2, which is congruent to 6, then by the transitive property, 3 is directly congruent to 6. This is the same thing as saying if A equals B and B equals C, A equals C. It's the exact same thing except for with congruency and angle measures. So that's question number 2. Okay, question number 3. This is a rather complex question. There's a lot of moving parts. So here we have a right square pyramid and a sphere made of marble. The dimensions of each figure are given, and the density of marble, we're told, is 160 pounds per cubic foot. When you see something like this, specifically this, cubic foot means we're going to be dealing with a volume. Once we've identified the fact that this is going to be a volume question, we're going to say, okay, we need to find the volume of that pyramid. We need to find the volume of that sphere. Once we have that, we can say, okay, what do we do with that information? You may know this or you may not. When we have a density, which here is given as 160 pounds per cubic foot, we're going to take the volume and multiply it by that 160 number, and that will give us the weight of each of these shapes. So our process is going to be, first, find the volume using the information given. Second, we're going to find the weight by multiplying each of these volumes by 160. And then this last section here, we're going to find the difference in pounds between the weight of the sphere and the weight of the pyramid. And that's just going to be a simple subtraction. We're going to find the weight of option 1 here, the weight of the pyramid. And then we're going to find the weight of this guy, the weight of the sphere. And we're going to find the difference between the two. And that'll be our final answer. So like I said, relatively complicated question. So let's just get into it. So here we have, I am going to move these equations out of the way. They will become relevant as we proceed. And let's start by finding the volume of that pyramid. I'm going to say volume Py, that's equal to 1/3. Big B in this context, you should know by now, is the area of the base. The area of the base of our square pyramid is 1.5 times 1.5. That is because the area of this square is base times height. And because it's a square, the base and the height are both 1.5. And we're also given the height is 2. So we can do some quick math here. Identify that 1.5 times 3, 1.5 times 2 is going to be 3. And then that 3 will cancel with that 3, and we'll be left with the answer 1.5 as the volume of the pyramid. You should have a calculator on your exam, and you can just do that math. You can do 1.5 times 1.5 times 2 divided by 3 and get the same thing. But if you happen to see that, that's wonderful too. Here we go. This one probably will not allow us to do any quick math like that, but we can give it a shot. So here we have, here we have 4/3 times pi r cubed. And what is our radius? Here you can see that we have a diameter of 2, and we know that radius is going to be precisely 1/2 of the diameter, which means that we have an r of 1. 4/3 pi times 1 cubed, which gives us just 4/3 pi. Okay, so now we have the two volumes. So I'm going to write these volumes up here. And we have a 1.5. And again, these volumes, by the way, are in cubic feet. You can tell because all of our measurements are in feet. So the resulting answers are in feet cubed. Forgot the pi. Okay. And now what do we need to do? So we determined earlier that our volume is then going to be multiplied by 160 to give us our weight. So let's go ahead and knock that out now. So I have for the called the weight of the pyramid is going to be that 1.5 number times the 160 number from the density. And that number is going to be 240. And then for the weight of the sphere, we have 4/3 times pi times 160. And here we're going to perform a bit of a simplification. Let me do some math here. And again, on your EOC exam, you'll have a calculator that is capable of handling this particular equation. This is going to get us to around 670.2. So now we have the weight of the sphere and the weight of the pyramid. And our weight total is going to be that 670.2 minus the 240 number. And this should give us around 430.2 pounds. So the final answer to this question, after finding the volume, multiplying it by the density, and then subtracting out, this is the final answer they're looking for. And this is a write in the answer question. So this is not a multiple choice. You actually have, this is an instance where you'll have to actually type 430.2 into the answer region, which is down there. So, all right, that's question number 3. Okay, so we're looking at question number 4, and before we jump too far into question number 4, I do want to specify, I believe that there is a typo. I believe this should be cubic inches, because the conversion from cubic centimeters to cubic inches is not given in your formula sheet, and I would be surprised if they wanted you to memorize that, because the conversion is 1 centimeter cubed is equal to 0.061 inches cubed. I'm going to assume that rather than forcing you to memorize that, they may have just made a typo in the question. So we're going to proceed as if this says cubic inches, because you'll notice in the table they're given, everything is per cubic inch right here and per cubic inch right here. So this is a relatively straightforward problem if you make that assumption. So let's just quickly read it over. So we have a scientist discovering a spherical object. It has a mass of 1.1 times 10 to the 25 grams and a volume of 2.9 times 10 to the 24 cubic inches. We're going to make that assumption. He uses the table shown to classify the planet based on its density. Select a word and enter a value and round to the nearest tenth. So this is a relatively straightforward question. Like I mentioned, if you make that assumption, all we have to do here is see, okay, we have grams per cubic inch. What that means mathematically is we have grams per or over inches cubed, and we're given the mass in grams is 1.1 times 10 to the 25, and we have a cubic inches measurement of 2.9 10 to the 24 times 10 to the 24, that is. And we know from algebra that if we have 10 to the 25th over 10 to the 24th, this is going to cancel the 1, and that's going to cancel the 0, which will leave us equal to 1.1 times 10 to the 1, or just times 10, over 2.9 times 1. 10 to the 0 is 1. And now, if you were to plug that into your calculator directly, you're going to get an answer of 3.79, which, by the way, this number verifies that I think this is a typo, because 3.79 is pretty close to what we're expecting to see here. So if we use this 3.79, this is the grams per cubic inch measurement of this spherical object. And now let's go to our answer. This object with 3.79 grams per cubic inch right here can be classified as what? If we have a gas, this measurement should be between 0.3 and 2.1, which it's not. And if it's between 3.6 and 13.4, which it is, it can be classified as rocky. So in this drop down, you only have two options, gas and rocky. We would choose rocky. And the reason is because its density is this 3.79 number that we determined by dividing here. So this is question number 4, a little bit easier than question number 3. Again, assuming you can make that assumption about cubic inches. So let's move on to question number 4. Pardon me, question number 5. Okay, question number 5. This one is a little bit more straightforward. We have Jalen here. He's constructing a circumscribed circle. And this is basically just a direct properties memorization question. I've already answered this, and we're just going to discuss it briefly. Select the line type that Jalen uses to construct the circle. You just have to know that if you're constructing a circle that is specifically circumscribed inside of a triangle like this, you are going to use angle bisectors. That's just something that you're going to have to study, and this is where I come back to saying review your notes, specifically your vocabulary. Unfortunately, a lot of geometry is just rote memorization, and this is kind of one of those examples where you just have to know this. And then they ask us to drag point X to that location, and the location of the center of the circle is where all of those angle bisectors meet in the center of the shape. So again, question number 5, more or less just a memorization question. You have to know that your angle bisectors allow you to draw that circumscribed circle interior to the triangle. On to question 6. Here we have question 6. The vertices of one of the diagonals of a square are located at -3, 4 and 2, -1. Our job is to find the vertices of the other diagonal and then comment on the properties of the diagonals of a square. So let's do this in reverse order. Here, this drop down, I haven't written the options for this drop down, but one of the options is that diagonals of a square are both congruent and perpendicular, and this is the correct statement here. This is more or less something that you have to know coming into the exam. You have to know the properties of diagonals of a few shapes, and for a square, the diagonals are both congruent and perpendicular. So that's the answer to the second part. So let's look at the first part. So we have the vertices of one of the diagonals is located at -3, 4 and 2, 1. 2, -1, that is. So one of the things we're going to need to do is find the slope. So we can do slope equals, oops. And I'm going to label this guy as x1, y1, x2, y2. So here we've determined that the slope of this diagonal is -1. And let's sketch this shape. So we know that we have a -3, 4, and we have a 2, -1. My diagonal that I just solved the slope for is here. So if you think about what does a slope of 1 or -1 mean, that means that this angle here is going to be 45, and it's going to be 45 in both places. That's because a slope of 1, if you think about this, if I start at this point and I go 1 up and 1 to the side, this is generating at 45, 45, 90, because I've generated a triangle with a right angle, and both that and that side are going to be the same. That's the definition of a 45, 45, 90. So if we extend that slope over the entire square, we have angle measures of 45 on both of where I've labeled here, here, and here. And what that means is that this and this is going to be a right angle here. But more importantly, there is parallelism with the axes. The axes for this problem are going to be somewhere in here. So what I've determined is the top and the bottom of this square are parallel to the x-axis, and the left and the right sides of this square are parallel to the y-axis. What does that mean? So that means that we have, if we want to find those two vertices, all we have to do is find the side length, which will be the same for all of them. This is a bit of a not to scale square. It looks like it's slightly longer than it is tall, but for a true square, all of these side lengths are going to be the same. And what that means is if we can find the side length, we know that the vertice locations of our missing vertices are going to be either directly above or below an existing vertex, or directly left and right of an existing vertex. So all we have to do is find the side length. So I'm going to remove some of this. And now let's redraw this 45, 45, 90. So this is side length of the square, and this is the diagonal shouldn't say side length, it should just say diagonal length. And what is our diagonal length? Our diagonal length is the distance formula for our 2 points that we're given, which is this formula here, distance formula, and these are all equal to each other. I'm just making algebraic steps. And here I have 5 squared is 25, negative 5 squared is 25, 25 plus 25 is 50. And I'm going to continue on here. Square root of 50 is equal to the square root of 5 times 5 times 2. These are just the prime factors of 50. And this is equal to square root of 5 squared times square root of 2, which is just equal to 5 root 2. So what I now know is that my my diagonal length is equal to 5 root 2. And again, we know that this is a 45, 45, 90 triangle because we found that the slope of that diagonal line was -1. So what that means is that my two side lengths here and here are going to be 5 square root of 2 over 2, square root of 2 specifically. And that we cancel, we get 5. This step here is the definition of a 45, 45, 90. I'm going to draw this up in the top left here. If I have a 45, 45, 90, and I have side lengths of x, my hypotenuse is x root 2. And that's the exact form you see here. We have square root of 2 times x, our side length. So with this information, we can proceed to solve the equation or the question that we have. So I have a box that is laying flat, and I have 2 points labeled -3, 4, and 2, -1. And now there's 2 ways to solve this. We know that every one of these side lengths is going to be 5. So I can do a couple things. For this point here, I'm just going to take this vertex here. I am going to fix the X position because this 2 is not going to change. And I am going to, for the -1, we're going up 5 because the side length is 5. We end up with +4. For this position, we have the same thing, but the other way around. So we're now fixing the -1, but we're going back 5. So 2 minus 3, pardon me, 2 minus 5 is -3. And this vertex here is -3, -1. And those are our final vertex locations. So we have -3, -1, and 2, 4. And we've answered question 6. Okay, question number 7. We have the pre-image and image of a circle are shown. One quick note, whenever we have a pre-image, post-image type question or a translation type question, you're going to see this notation. We have a variable that denotes a shape, or in this case, a circle. And then we have that variable prime. In this case, G is denoting the circle before change, and the G prime is where it's going to end up, or after change. And this change can be either translation, we can do growth or shrinking, reflections of any kind. Anytime a shape changes, it's going to be denoted, that change is going to be denoted with this prime indication. So that being said, let's get into this particular problem. So here we have a center of circle G is at the origin 0, 0. And the center of the circle G prime, this is of course after it moves, is 1, 1. The radius of circle G is 5 units, and the radius of circle G prime is 4 units. And they specify the sequence of transformations is shown, and this is in order. We have step 1, step 2. So let's first draw again this, because in this diagram here I have 2 circles overlapped, and it also doesn't show the intermediate step. So I'm actually going to draw my own coordinate plane with my own G circle, and we're told that this initial circle has radius of 5 units. So this is going to be 5, 5, 5, and 5. And my ability to draw circles is questionable, but we're gonna see, not great. I'm going to shift the goalpost here and make it look like I perfectly hit 5 on everyone. Would you look at that? Okay, so I have a circle with radius 5, and it tells me that the radius of my new circle, circle G, is 4. Sorry, G prime specifically. It's important to note the prime. So G prime is 4. So here I have, let's label off 4, and I'm going to draw my new circle, which gets slightly smaller. Another note, if you are multiplying by a variable, you see in step 1 we have cx, cy. C greater than 1 indicates growth. C less than 1 indicates, I was going to say decay, shrinking. So we know that because this started at a radius of 5 and turned into a radius of 4, we're going to have a C value less than 1. And specifically, how much did it shrink by? We can actually grab a specific point and check to see how much it shrunk. So if I look at this point on the circle for G before it shrunk, I have 0, 5. And then this same point after shrinking, it basically just moved directly to the left. That point here, I'm going to grab G prime, is 0, 4, right? Because the new radius all along the outside of the circle is 4. So all these points that it touches on the axis are 4. So what does that mean? Basically what we're saying with this, if we look back at our sequence of transformation, this guy here is saying that I'm going to multiply my x and my y coordinate by some constant, and that is going to give me the new coordinates. So we know that my coordinates are going to be initially 0, 5, and then I multiply some c to both, and that gives me 0, 4. Well, anything I multiply to 0 stays 0, so that doesn't really help me. But here I can see that 5 times c is going to give me 4. That's an algebraic expression that I can actually just write out. 5c equals 4. And now I can solve for c. This is a relatively straightforward process. And we get, canceling out here, c equals 4 over 5. And they want this in numeric form. 4 divided by 5, you can plug that into your calculator, 0.8. So I'm just going to box this guy out here. So my c is 0.8. So that's part 1 of this problem. Now we can deal with part number 2. And I didn't properly circle my work, so let's try again. Okay. So part number 2 of this is it's then going to translate by some constant d. And we can do the same process. You can actually use the origin for this, but it'll work for any position on the edge of the circle. Just like we did with when we were growing and shrinking. Any position on the circle, including the origin, can be used to solve for this d. I'm going to use the origin because it's the easiest to see what's happening. My original G location, the center of G, is at the origin 0, 0. And then after some movement, we end up at a center of 1, 1. If I write this kind of in the way that I did earlier, again, referencing this translation, I'm going to do my initial center, and I'm going to add some d to both x and y, and I'm going to end up at 1, 1. So again, we can just draw a direct algebraic expression here. 0 plus d equals 1. This is actually true for both x and y here. You can see that both of them are 0 plus d, resulting in 1. And this is an extremely easy algebraic expression because anything plus 0 is just itself, and we end up with d equals 1. So here I write down 1 for d. And this is my answer. C equals 0.8 and d equals 1. And that's all they're looking for. So let's move on to question number 8. Here we have a relatively straightforward trigonometry question. We have a figure shown, and we have a indicated degree measure in the bottom right hand corner of this triangle. And we're asked to complete the trigonomic ratio. It's helpful in this particular case to identify where the opposite, adjacent, and hypotenuse are relative to that theta. So the opposite is going to be the square root of 32. The adjacent is going to be 2. And the hypotenuse is going to be 6. We then will use our SOHCAHTOA. That's SOHCAHFOA. Let's do SOHCAHTOA. And we're going to use tangent, which is opposite over adjacent. And this, for this particular triangle as we've defined it, is square root of 32 over 2. And all you would see is for these drop downs, you would have square root of 32 for that drop down and 2 for that drop down. So this is a pretty straightforward question, as long as you know how to properly identify which parts of a triangle are opposite of a angle, and then as long as you know your SOHCAHTOA, this one should be a free one. Okay, this is a particularly algebra heavy question. So what we have here is a equation of a circle, but it's given in a very non-standard equation of a circle type way. And our job is going to be to transform this into our equation for a circle, which we know to be x minus h squared plus y minus k squared equals r squared, where for this particular notation, hk is the center of the circle, and my r is the radius. So, how do we proceed? For this particular question, we're going to implement the completing the square, which we learned in Algebra 1. That way we can find these factored y minus k and x minus h, both squared type portions of the expression. And we also want this negative 27 to turn into a positive number. And that'll happen once we take the completing the squares, because we should get a bunch of positive values resulting from completing the square. So let's see it in action. So I'm going to break this into two sections. I am going to do the x squared plus 8x part first, and then I'm going to do the y squared minus 12y part second. So here, x squared plus 8x. In order to complete the square, we take b, divide it by 2, and then square it. This gives me 4 squared, which is positive 16. For the y section, I have y squared minus 12y. Again, I'm going to do negative 12 over 2 squared. Negative 12 over 2, negative 6. Negative 6 squared is positive 36. So now what I've done is I've taken this first part and I've turned it into this guy. And I'm taking this second part and turning it into this guy. I'm going to rewrite the equation. That way you can see this whole thing at once. Oops. So, one note before we continue here. This 16 and this 36, these don't currently exist in the equation as it's written. So when we add them in on this next step, we're going to also need to add them both to the right-hand side of the equation. We know from algebra that whenever we do something to the left side of the equation, we have to do the same thing to the right side of the equation in order to keep it equal. So I'm going to take my x squared plus 8x, and I'm going to substitute in my x squared plus 8x plus 16 from our completing the square portion earlier. And then I'm going to do the same thing to this y portion, which is to turn it into y squared minus 12y plus 36. And this is all equal to that negative 27, but remember, we now have to add in the 16, and we also have to add in the 36 that weren't in the initial equation. So let's take a look. I can put brackets around these to make things a little bit more clear what I'm about to do. X squared plus 8x plus 16. The whole motivation behind completing the square was making this polynomial much more easy to factor. This is going to turn into x plus b, where our new b is b over 2. So we have this 8. Completing the square makes this into x plus 4 squared. Same thing with this y. Instead of having this more complicated polynomial, this just turns into whatever my b is, negative 12 divided by 2, which is negative 6 squared. And then negative 27 plus 16 plus 36 turns into positive 25. Now you can see we're one step away from having this in the typical equation for a circle equation. So I'm going to keep everything I've done so far. And if you're paying attention, you know that 25 is equal to 5 squared. And now we're in a position to simply label things. I have h is equal to negative 4. It's critically important you notice that this is a negative. In my initial going back up to the original equation for a circle, we have x minus h, and here we have a plus sign. That means that it's a double negative. H equals negative 4. For this guy, we just have simply y minus k, or y minus 6, so k equals 6. And here I have r equals 5. So going back to final answer, I have my h is negative 4, which is the x value of the center. K is positive 6, and a radius of 5 units. And that is the final answer. Okay, question number 10. Here we have a pentagon, and we're going to do a translation 2 units to the left, followed by a reflection over the y-axis. And the question here is basically saying, what does that shape look like after both of those things have happened? So the translation is pretty straightforward. Whenever you are translating a shape, the shape has to be made up of individual coordinates. And when we do a translation, we're just going to move every single one of those coordinates 2 units to the left in this case. So that will look something like this. B moves to the left, A moves to the left, E moves to the left, D moves to the left, and C moves to the left. I'm not going to label all these just because it'll get very busy in this coordinate plane if I start labeling everything, but it's pretty clear to see which point is which here. Basically the entire shape shifted to the left. Now we're going to perform a reflection over the y-axis. Y-axis is right here. And what that means is we're going to draw a perpendicular line across the y-axis in this case for each of the lines. And in this case, because the y-axis is straight up and down, a perpendicular line is a perfectly flat line. And the amount that it reflects is dependent on how far it is from the axis. So you see here, what was point A was 1 unit away from the y-axis. So it went 1 unit to get to the y-axis, and then it went another unit to reflect across it. That same procedure is going to happen for every one of these. So B is 1, 2, 3, 4 units away. So we need to go another 4 units, 1, 2, 3, 4, to get the new location of B. Again, notice that because we're reflecting over the y-axis, that there is no y component to this reflection. All the new reflected points are all going to be simply changes in x. So let's do this continuing for everything, all the other points. So we have E, which is 2 units away. So we're going to continue 1, 2. Here we have D, which is at 0.6. Again, another way to look at this is you can simply look, if we're reflecting directly over the y-axis, you can simply look at the x value and then make it negative. So this is D is going to be at +6, +2. Our new D, D prime, is going to be -6, +2. 2 didn't change, but our x went from positive to negative, and that looks something like this right here. And our final value here of C is at +7, +5, which means we're going to end up at -7, +5, which is somewhere in here. And this is our final shape. If you were in the exam, you see here there would be a connect a line tool in order to draw this shape. I've just drawn it manually, and my lines weren't perfect, but you get the idea. The coordinates are in the right place, and that's what's the important part. On to question 11. Okay, question number 11 is pretty straightforward. We're given a diagram and a statement about the diagram, and our job is to disprove the statement. So here Corey has told us that when a transversal intersects parallel lines, two angles are supplementary if and only if they are adjacent angles. What that if and only if means, that's a very powerful statement in math. What that means is the only time that we can have supplementary angles is if they're also adjacent. So all we have to do is find one pair of angles that is supplementary but not adjacent, and we will have disproven the statement. Before we go any further, I will give you a quick definition of supplementary. Angle A plus angle B equals 180 degrees. Angle A and angle B are supplementary if their sum adds to 180 degrees. That's something that you should know going into the exam. I'm just giving it here so you're aware of what we're about to do. So if I go up to this diagram, I can find a couple of angles that actually disprove this. I'm going to call this angle 1, this angle 2, and this angle 3. So angle 1 and angle 2 are supplementary. They add up to 180 degrees. But you may notice here that angle 2 and angle 3 are actually equal to each other. And what that means is that I can substitute in angle 3 and still get a supplementary. I still have, I'm going to move this down to here a little bit, angle 1 plus angle 3 equals 180 degrees. Here, I've proven that angle 1 and angle 3 are supplementary, but you can see that angle 1 and angle 3, if I look back at my diagram, these guys are not adjacent. Therefore, I found a counterexample to this statement from Corey, and all I have to do is say, okay, angle 1 is FGH right here, and angle 3 is PMG, this guy right here. And that's the answer. All you have to do is select those two, and you've found a counterexample to the statement and answered question 11. Okay, question number 12 is basically a vocabulary question, but it has a bit of a strange lead up. So let's talk about what's happening off to the left here. So we have angle A, which is generated by having a point with two rays extending out. And the first thing we do is we're going to place a compass at point A, and we're going to draw arcs that intersect both rays. For those of you who are not as familiar with compasses, basically a compass is going to generate a circle. And this circle, obviously with all circles, all the points on the edge of the circle are equidistant, which means that both B and C are going to be equidistant from A, which by extension of that logic, we have line AB and line AC being equal. Now we're going to take that same compass, and they specify the same compass width, and we're going to draw intersecting arcs at point D. The same compass width portion here is specifying that my distance here and here is going to be the same distance as our A and B. And I've drawn here A to B, B to D, D to C, and C to A are now all equally distant from each other. And now I'm going to draw a line A to D. What we've generated here is two triangles which by side are congruent, because A to B is the same as A to C, B to D is the same as C to D, and then they both share this internal side length here, D to A, or A to D. Not only are they congruent, but this angle and this angle are equal, and this angle and this angle are equal. The important part of that, though, and this is getting a little bit messy, so let me erase some of this. The important part of this is that these two angles are equal. Again, I'll simplify this just a little bit. Two triangles that are congruent, that angle and that angle, as well as that angle and that angle, are congruent. So now we can go to part A. Part A says select phrases to create a true statement. And here we have constructing AD, which we've already done, will create two congruent angles. That's what I was already mentioning here. So this is DAC, and this is inside of this drop down, DAC and BAD. That was one of the options inside of that drop down. The reason is because AD is an angle bisector. Anytime you have any angle and you draw a line that has two, this is not to scale, that's an ugly version, but you get the idea. If these guys were, let me draw it a little bit clearer here. That's a little bit better. If I drew a line that had these two angles, this guy and this guy, be equal, this line that I've drawn here is an angle bisector because it's directly bisecting or cutting in half directly an angle. This is what I mentioned at the beginning of this question. This is just going to be a vocabulary question. You just have to know what an angle bisector is coming into the EOC. But this statement is now true, so we've constructed AD, which creates two congruent angles because it's an angle bisector. And this second part, part B, we've also kind of discussed in pretty significant detail, which is to say that all of the side lengths of this shape are equal, because you can follow the construction. A to B and A to C are equal, and then we took that distance from B to D and C to D. So all that being said, all of the sides of this four-sided shape that we ended up generating are going to be equal, and that is AC, BD, and CD are all equivalent to AB. So that is question number 12. Okay, question 13. We have a figure composed of a right cone and a right cylinder with dimensions in feet. And we are to find the surface area in square feet. So we don't need to do any conversions. We're just going to find the direct surface area using the dimensions in this shape. I have written out the equations of surface area for both cylinder and cone as they appear on your reference sheet that you'll be given on the exam day. Here we can see that the surface area of a cylinder is equal to 2 times the base plus the perimeter times height. And the surface area of the cone is base plus pi r slant height. But you may notice one thing if you've done these types of questions before. We have a circular area here, which is both this B and it's also one of those B's. And because that circular shape is on the interior, we actually need to discount it from the final total, because we don't, the definition of surface area is it has to be on the surface of the shape, and that circle is an interior surface. So I'm actually going to rewrite both of these equations for what we need to find for this particular question. The surface area of this particular cone is just, it's called the lateral surface area, or pi RL. It's this portion of the surface area of the cone. And for the cylinder, we're just going to do, I'm going to shorten that to sil equals 1b, which is this guy. This guy is still on the surface, so we're going to include that in the surface area equation, but not the top one. So 1b plus, and that perimeter times height is the same. This perimeter, by the way, you'll notice in our equation sheet, it's given as perimeter. This is actually for a cylinder. This is going to be the circumference of the circle on the base. So, all right, so let's move some stuff around so we have some space. I'm going to grab this, which is actually relevant to us. I'm going to move it up here. And then I'm just going to get rid of everything else for now. And let's get started. So let's find the lateral surface area of the cone first. That's just going to be, that's going to be pi times r times length, which is equal to pi times the radius, which we're given is 1.5 directly. By the way, this radius 1.5 here is the same radius here. These are both 1.5. That doesn't change throughout the cylinder. So here we have pi times r, which is 1.5, times the lateral, pardon me, not the lateral surface, the slant height of 2.5. And if we plug that into our calculator, give me 1 second. We're going to get 12 point, I'm just going to call it 0.2. I'm going to be a little more specific because they're asking us for an exact surface area, so I just want to get as close as possible to the real number. So we have a surface area of this top portion of 12.02, and now let's find the remaining surface area that is made up of that bottom cylinder. And that is going to be 1 base, which is that bottom base, plus what is called pH. So let's break this into 2 sections here. So I've got a base, which is the area of, again, this circle down here, which if you know your area of a circle, you should. It's pi times r squared. And then for my perimeter, which is actually going to be the circumference of that circle, circumference of a circle you should probably also know is 2 pi r times h, which I'm writing this out right now as variables. And now we can go in and let's do some substitution. So we've already established that the radius is 1.5. That's the same radius for this guy. And we're given a height of 3. So again, go ahead and go to your calculator, and I will also perform this calculation. And I am getting a result of approximately 35.34. So now I have established the surface area of this conical top shape right here, and then I've also established both the side and the base of that cone. And now all I have to do is add everything together. So I've got, I'm going to call it surface area total is equal to 12.02 plus 35.34. And one last time I'm going to go to my calculator. And I am getting a value of 47.36. So this is my final answer for the surface area, and in case it's asked, I don't know if it would be here or not. I don't see a section asking for it, but I would specify that this is in square feet because all of the particular units up to this point have been in feet, and it's asking for it in square feet. So final answer, 47.36 square feet for question number 13. Okay, 14. Angelo transforms a rectangle. The corresponding sides of these rectangles after the transformation are not congruent. So what we have here is any transformation that is going to change the magnitude of the side length. The critically important part of this is that the side length needs to be preserved. So if I have, for example, a translation that looks like XY arrow CX CY, which is what most of these look like, I need to choose a absolute value of C that is not equal to 1. Why is this an absolute value? Think about the following. If I have 2 points that are -1 away, and I have 2 points that are +1 away, the total magnitude, the total distance between those 2 points is the same. The negative in this case refers to a direction. However, for congruent sides, specifically this question is saying side congruency that it's interested in, and specifically not congruent. We're looking for a C that is not equal to 1 in magnitude specifically. It doesn't matter what direction it is, it just matters that the magnitude changes. And for the magnitude to change, you have to have a C value that is any number except for 1 or -1. So with that knowledge in mind, knowing that we're looking for a change in magnitude, let's take a look here. So the magnitudes are going to be preserved because what we're doing here, we have, even though we have a mirroring effect here, the actual side lengths themselves are going to remain constant. No change will occur between this transformation in terms of side length. However, when we get to this guy, you notice that we are drastically increasing the side lengths. So for this, we're actually going to mark this because this is a transformation that Angelo could have used to make PQRS have non-congruent sides. If you have a side length that's 3 times larger than its original side length, it is not congruent anymore. This is why I specifically mentioned magnitude is important, because this, let's call this C, this guy here actually does maintain congruent side lengths. What I was talking about here earlier is basically just saying that while the direction may change, the magnitude of the side length does not change, and as a result, C actually does maintain side congruency. D, we can just clearly mark here. We see that we have side length changing. Both side lengths are going to be changed by 1.5, at which point the side length is no longer going to be congruent to the original side length. It's going to be 1.5 times larger. That change is what we're looking for. And then for E, this is a shift. Shifts are not going to change the overall side length of the shape. So this rectangle, when it shifts 2 to the left and up 3, is going to maintain its original side length. It's going to remain the same rectangle even though it shifted 2 to the left and 3 up. So the only time where you're going to see a non-congruency in side lengths is if you multiply one of the side lengths by some non-1 value, and the only times that happens is for option B and option D in this particular question. Okay, last question, question number 15. Unfortunately, this is a little bit of a longer one, but the fact that we are very close to the end will hopefully get us through this. So let's take a look. We have point P, which is labeled as -1,4, is lying on a segment QR with endpoints of Q17 and R -9, -8. And we are going to match each ratio of segment lengths to the corresponding numerical ratio. What this is basically saying is all we need to do is solve for QP, solve for PR, and solve for QR. Specifically the distances between QP, PR, and QR. And once we have those numbers, the actual distances there, we can then solve for the ratios, because this is just a number, a distance represented by a number, and this is a distance represented by a number, and I can find the ratio, and then hopefully that ratio represents 1/4, 1/5, or 4/5. So let's get started by simply finding some of these distances. So QP, let's label Q is, we'll rewrite it here, is 1,7, and I'm going to preemptively call this x1, y1, because I'm about to do the distance formula. And I'm going to find P, which is -1, 4. And this is x2, y2. Just to demarcate that so it's obvious which one is x1 and which one is x2. And let's do the distance formula. So we have square root of x2 minus x1 squared plus y2 minus y1 squared. And here specifically I have -1 minus 1 squared plus 7 squared. This is equal to 2 squared plus 3 squared. Specifically, I'll write here, I was going to do a shortcut, but I think I'll be more thorough with this just because I'm showing the specific distance formula. So we have -2 squared is 4, -3 squared is 9. And that is equal to square root of 13. I am going to, in order to save some space, I am going to say QP equals 13, and then I am going to grab QP equals 13 and move him up here, and then I'm going to get rid of some of this. Okay. So we have QP equals the square root of 13. So now let's find PR. P is still negative 1, 4. Again, let's label this here, and R is negative 9, negative 8. And I'll call this x2, y2. I mislabeled this guy. So now we have x1, y1, x2, y2. Now let's do the distance formula again. So we have, and this is why I said at the beginning, this is just going to be a long question. It's just going to be distance formula after distance formula after distance formula, but we're so close to the end, might as well just knock it out and be done with it. So we've got negative 9 minus negative 1 squared plus negative 8 minus 4 squared. This is going to be 10 squared. No, it's not. It's going to be negative 8 squared, because negative 9 minus negative 1 is negative 9 plus 1, which is negative 8. And negative 8 minus 4 is negative 12 squared. This guy is equal to the square root of 64 plus 144, which I am going to do some quick calculations here. And actually, let's leave this. I was going to do the whole thing, but actually let's leave this in square root terms for now. So this is square root of 208. And I am betting that this divides by 13, and it totally does. So here we have 208. In your exam, you'll want to break this down into its factors, and after you do that, you're going to get the square root of 208 is equal to the square root of 16 times 13, which is equal to the square root of 16 times the square root of 13, which is equal to 4 square roots of 13. So following in our tradition of labeling this and then moving out of the way, we now have PR is equal to 4 times the square root of 13. Just as a quick heads up, I was able to see this because I saw that square root of 13 was a bit of a weird number, and I was making the guess that the number 208 was going to evenly fit into square root of 13 somehow. That's why I initially did this breakup of 16 and 13. And it turns out that it is indeed precisely 4 times larger. PR is exactly 4 times larger than QP. If you were in a test environment and you didn't see that initially, you would still get to this 4 root 13 number either by, there's a couple ways to do it. You can just stick with this square root of 208 number, plug it into your calculator, and then divide it by this square root of 13 number, and you would still get that they're 4 times, PR is 4 times larger than QP. This is basically just a more mathematically precise way of showing that that's the case. So I'm just going to move this up here. And I'm going to remove all this stuff again. Whoops. Okay. And now we can do the last guy. So we've done QP is equal to square root of 13. PR is equal to 4 times the square root of 13. And now we need to do QR. So one last shot here. Let's do Q and let's do R. Q is equal to 1, 7, which we're going to call X1 and Y1. It's a little ugly. Let's try that again. And then here R is equal to -9, -8. And again, one last distance formula. So here we have, I didn't label these, let's label this X2, Y2. So we're going to do -8 minus 7 squared, -9 minus 1 squared. This gives me 15 squared, which is a rather large number, and -10 squared. This is going to be, I believe that's 225 plus 100, but let me just do the math on a calculator so I don't make a mistake. So that is indeed 225 plus 100, which is equal to the square root of 325. If I take 325 and divide it by 13, let's see if I get another even number, and I might, and indeed I do. So this is, again, following the same logic, square root of 325 is equal to square root of 25 times 13, which is equal to square root of 25 times square root of 13, which is equal to 5 root 13. And one last time, I am going to specify this is QR, and then I am going to grab him and move him up here. So now I have my 3 lengths that I was interested in, which is QP, PR, and QR. And now what are we looking for? We are looking for the ratio QP to PR. So let's write QP over PR. This is equal to square root of 13 over 4 square root of 13. If I cancel out square root of 13, I get 1 over 4, which is that option there. And now let's do the same thing for QP over QR. And here we have QP again being root 13 and QR being 5 root 13. Again, same method here. I'm going to cross out those 13s and I get the square root of 13s, that is, and I get 1 over 5, which is this option here. And that is the answer to 15 and the conclusion of the test. All right, that's it. That was a great review. I hope you guys got a lot out of that. Please stay tuned and subscribe. This is the first of a few reviews that are going to come out for geometry. This is primarily the long-form centralized EOC review. I want to keep the whole official Florida Department of Education EOC review in this video, and as you can see, that makes it pretty long. Future videos that are coming out over the next couple of weeks should be shorter form, about 4 to 5 questions, and a more digestible length, probably around 10 to 15 minutes. And the frequency that these are going to come out is actually pretty fast. I'm thinking around every other day posting at least one of these videos from now until exam day. So I'm hoping that a large amount of review material should help you better prepare for your test. And if you appreciate this video but feel like you could use some extra help and you feel like supporting me, I've started a Patreon page where you can access a direct email hotline for any specific questions you have. And I'll be answering those questions with detailed reports and a pretty in-depth write-up in order to help you understand the material the best I can. And this can be homework review questions, EOC questions, like if you have an exam question on a practice test that you've been given and you either don't know how to start the question, or if you're getting a different answer than is on an answer key, or anything like that, feel free to go over there and check out the Patreon page, and I am more than happy to help. Currently, the video repository on that Patreon is small because we just started, but we're going to go quickly, and we're going to try to get some great videos on Patreon as fast as possible. The primary benefit of that Patreon right now is that email hotline. But all that being said, stay tuned on this channel for a lot more EOC review material, and have a good rest of your day, and good luck on the EOC exam.